this also probably in chemistry. Qualitative data, quantitative data. You're going to see both. On the AP exam, you'll see both. In here, you're going to see both. Qualitative data is descriptive. Next week when we're doing our experiment with the worms, one of the things you will write down will be the color of the worms. What do they look like? How do they behave? How do they interact with each other? Then you'll also take down quantitative data, which is your numerical data, which is where your graphs and things like that are going to come from. So qualitative, quantitative. There are lots of different types of graphs. On the AP exam, you'll see lots of graphs. You also will encounter things like graphs that are called bar and whiskers graphs, graphs that are called scatter plots, pie charts. There's only two main ones, though, that you're going to see in here in class time and or be asked to draw yourself. And those two are your bar graphs and your line graphs. So how do you know which one to do? If they don't tell you, sometimes you get lucky and they just say, make a line graph in which case perfect, they've told you what kind of graph they want. If they don't, though, your line graph is going to be for continuous data. Anytime both of your variables are numbers, this is where you're going to see specifically a line graph. For example, if you were doing the amount of enzymes, or the amount of product, I should say, that was produced over a period of time, you might have a line graph. So here you have your time on the X, and you have numbers, and then you have some amount of something that's being made, maybe in grams. This would be a really good example of where you'd want to use a line graph. A bar graph, on the other hand, is what you're going to use when one of your variables is not a number. For example, if you were looking at, let's say what color shirts everybody was wearing, and your options were teal, gray, black, let's say in white. And then this would be the number of people. One of your pieces of data is not numerical, which is our colors of shirts. So this would make way more sense to be a bar graph. So that's how you're going to make your decision, and we'll do some practice ones in a second, but that's going to be the distinguishing factor. Again, they may tell you what kind of graph they want, which makes it even better, but that's going to be your rule of thumb if they don't tell you specifically what graph they want you to use. All right. Some more about graphing. Your independent variables should be on your x-axis, always. Unless they tell you something different. Your dependent variable is going to be your y-axis. Again, sometimes you get lucky and they tell you exactly what they want you to put where, but if they don't, this is going to be your rule of thumb. You're going to take whatever your independent variable was, that will make your x. Your independent variable, your dependent variable will become your y-axis. Also, you're not going to have to do this very often, but you should recognize what it is. Sometimes you'll get data that follows a pattern, but it's not perfect, because in real life, data is just not going to probably come out perfect. So sometimes you'll see something like this, and your data, the points do like this. And then what you will see, or you may be asked to do, is to make a line of best fit. So just so you know what a line of best fit is, it's where you try to create a line that sort of hits most of the points, or is an average between the points. That's what a line of best fit is. If you are unsure, if you have some data and you're doing a lab for me, and you're like, do you want me to make a line of best fit, or do you want me to connect the dots? Just ask, and I will be glad to tell you. Luckily, on the AP exam, I think in the last 6 years, anytime they've asked you to draw a graph, they gave perfect data. So it was never a problem. It made a perfect line, or it made a perfect, bell curve, or it did something like this. But you were able to make something smooth that didn't look crazy and jaggedy without having to worry about trying to figure out what a best fit line was. But just be aware of what it is. And that is what it is. All right. Also, or actually before we do the also, here's some practice ones. So we're going to go through these really quick. I want you to tell me which kind of graph. I know there's more rules there on your papers. And what goes on the x and y. First of all, x-axis is going to be which variable, did I say? So this is our independent variable. Our y-axis is going to be our dependent variable. So here's our first one. So how many schools use iPads in Dade County versus Broward County? So which one of those things should be our x-axis? The number of schools or the county? The county is what we are comparing. So Broward County and Dade County, that will be our x-axis because that's our independent variable. And then the number of schools will be our y-axis because that's actually the measurements, the data that we're going to collect. Think of your y-axis as being the data that you actually collect. You're not in control of that. All right. Oh, and by the way, bar graph or line graph on that first one? Bar graph, right? Broward and Dade are not numbers. How about this one? I already told you the answer. Polos versus spirit shirts on a Friday, bar or line? This would also be a bar graph. Which thing should go on the x-axis? The number of students or the type of shirt? Good. Type of shirt would be your x-axis, and then the data you collect, the number of students, would be your y-axis. All right, our next one. Number of milligrams of fertilizer that produced the best plant growth. And let's just specify for plant growth that for this experiment, we're going to be measuring their height. So line graph or bar graph? Good. This would be an excellent example of where you'd want to use a line graph. Everything's numerical. Milligrams is an amount of fertilizer, and height is going to be at centimeters or meters or millimeters or something like that. What is our x-axis? Milligrams of fertilizer or the height of the plants? Now I hear mumbling. Which one do you control? You control the fertilizer. So that's our x-axis. That's our independent variable. You don't control the height. They grow however they grow in response to the fertilizer. So your height's going to be your y-axis. Next one, distance, how the distance from light correlates with the amount. This says with oxygen production. Let's assume this is an amount, a numerical amount of oxygen production. Would this be a line graph or a bar graph? This would also be a line graph, two numbers, amount of production and distance. Which thing is our x-axis, the distance from the light or how much oxygen they make? Good. Distance from the light is what you are controlling. You will move the plants. The amount of oxygen that they make, that's going to be your dependent variable. So that's your y-axis. All right, and last but not least, the speed at which an enzyme makes product at different pHs. So we've got pHs, and then we've got speed, which is a rate, which is also a number. So would this be line or bar? This would be a line graph. Some people were a little iffy on this because of pH, but pHs are numbers. It's a range. It's a scale. So I would say we would definitely use a line graph here. Which one of those things is our x-axis, pH or the speed of production? Good, pH. That's what we are changing. We are going to provide the pH, and then the speed of production, the rate that they produce product, would be our y-axis. You should be able to do this if I gave you a sample experiment on a test and I asked you which kind of graph you should make and to identify what should go on which axis, you should be able to do this. So, and we'll review it again. But let me know if you, if you have any questions on it. If you're still struggling with it as we get into next week, let me know. But hopefully that clarifies it with the practice there. Okay. Couple more rules to wrap this up, and then we're going to go to the one you did on the pretest. Graph should have a descriptive title. Usually you're going to put, for example, for the one that you did on the pretest, you might have put amount of oxygen during the day or something like that. Something that sort of just describes what it's showing. Second, label your axis with units. This is a huge mistake. People do this a lot. For example, let's say you have data, and the data that you have is the amount of oxygen, and that's what you're measuring, and let's say we were doing the distance from the light. A lot of times what they'll have here in parentheses, they'll have like milliliters, and they'll have, let's say, centimeters here. When you do your graph, some people forget to label the axis altogether, but some people remember to label it, and they write here amount of oxygen and distance, but if you do not include the units, which is milliliters and centimeters here, they won't give you credit. They will count it as if you forgot your units altogether. So it's really important that you include the units when you label, or you won't get that point. You don't lose points on the AP exam, just to clarify. On the short answer part, you just earn points. So you might have a graph, and it's worth 4 points. And each thing you do correct earns you another point. So in order to earn the point for labeling the axis, you have to make sure you include units. If they don't give you any units, just include whatever they give you. But make sure you don't omit that part of it, or they will basically count it as if you forgot to label the axis completely. Next, don't go beyond your first and last measurement. A lot of times you're tempted to continue a line, turn it into an array with an arrow at the end and let it keep going, but you don't want to do that. On the one that you guys did, it started at 6 a.m., which you may have put out here, and the last measurement that was taken was at midnight. If you put 6 a.m. here and you put midnight here, and then you have your dots, your line connecting those dots should not have extended past 6 a.m. here, and it should not have extended past midnight here. Anytime you continue a line, it means you have data on the other side of it to support it. So you're not allowed to continue to start prior to or extend beyond your last data point. So that's another place where they would not give you credit for the proper line graph if you put your data past the points they gave you. What you are allowed to do is if you want to continue a line and show that it's what you think the trend would be, you can make it a dotted line. Dotted line automatically means prediction. It's saying this is where the last data point I have is, but I predict that this is what would happen afterwards. So be really careful. That may be a point that some people missed on the pretest. We'll go over it in a few minutes. A lot of people want to continue past the data points. You do not have to start at 0. That's something that's kind of been forced into your head in certain classes. But if the first data point you have is 100, don't try to make a graph. All your data points are between 100 and 200. You don't want to try to start at 0 and then not have any data until you get way up here and you can barely even see it. You can just start at 100. That's fine. If it makes you feel better, you can also make one of these little break lines showing that you're starting at a higher number, but that's not even necessary. You can just start your data at whatever. Look at your data first. Look at what your highest point is, what your lowest point is, and then just create a scale that'll fill your graph nicely. But you do not ever have to start at 0, 0. That is completely unnecessary. So that's something to keep in mind. And last but not least, spacing on your graph has to be proportional. And what I mean by that is, I don't mean that if you do hundreds here, you have to do hundreds on the other axis too. On the two axes, this one might go by hundreds. Whoops, sorry about that. This one might go by hundreds, and this one might go by ones. That's not a problem. That you are allowed to do. But what you're not allowed to do, that I have seen people do, is something like this, where they do this. They go 5, 10, 20, 50, and they keep going. If you've decided that the distance from here to here is 5, then you need to make the distance between here to here 5, and here to here 5, and here to here 5. Whatever scale you choose, you have to stick with it. So if you know you've got to get to 50, come up with a scale that will make your numbers fit and get up to 50. Do it in tens. If your data is going to go to 100, maybe you want to do your scale in 20s or 25, 50, 75. Just don't change scale midway. You're not allowed to do that. All right, so that's, I believe, the last of the rules. What we're going to do now is we're actually going to, if you want to open up number 1 on your pretest, we're going to score it and see how you would have done with following the graphing rules. So if you want to open that up,